আমরা এখন আমাদের যে ফর্মাল প্রেজেন্টেশনে চলে যাব। আমাদের প্রথম প্রেজেন্টেশনটা দিবেন হচ্ছে মাফিনার খান। উনি কাজ করেন হচ্ছে প্রোডাক্ট ম্যানেজার Panacea Systems Ltd এবং ওনার কোম্পানিতে আগাগোড়া সব কাজ হয় পাইথনে এবং ওনারা কাস্টম বিজনেস অ্যাপ্লিকেশন বানান, ক্লাউড বেসড অ্যাপ্লিকেশন বানান এবং মালয়েশিয়াতে একটা স্কুল অটোমেশন সফটওয়্যার ওনারা চালাচ্ছেন এবং তাদের পুরোটা হচ্ছে ফুল স্ট্যাক হচ্ছে পাইথনে। তো আমি মাফিনার খানকে আমন্ত্রণ জানাচ্ছি।
Good morning, everyone. Before I start anything, let me say that I feel wonderful to be in the presence of so many local Python programmers here. Thank you for making Pycon a success. My topic is going to be cool features of Python. Well, we all know that Python's a very cool language, and there are like way too many cool stuff, and it was a little bit problematic for me to pick up one cool thing or one or two cool things to fit the time. But what I did was I picked up a couple of them and then placed it in front. About me, I am Mafinar Khan. I am the product manager of Panacea Systems Ltd, and you can see my Twitter and the website of our company over here. Alright, let's get started now. I will start off with the 4 P's of Python. It's kind of like a thing that I've started off with. It's the 4 P's are pleasant, powerful, productive, and the philosophy. Python is an amazingly pleasant programming language to get started with. Most of us who started off with Python from a different language agree that it's very easy and it's like very easy on the eye and easy on the mind. But just because it's easy does not make it any less powerful. It is extremely powerful, and you can express yourself in a lot of ways in Python as you can with many other functional or even object-oriented languages. And once you put productive in one hand and power in the other, you automatically become productive. So pleasant plus powerful equals productive, and hence it is a very productive language. And another very important thing about Python is that it's very philosophy-driven. Like, there are some best practices which the Pythonists follow very tremendously. Okay, let's start off with pleasantries. Python is very easy to get up and running with. It's like right after 20 minutes of doing it, it becomes very familiar. Some people even call it executable pseudocode. It's like, you know, what we write to define normal algorithms. Actual executing Python code looks exactly the same at times. It is dynamic, so you don't have to worry about the typings or anything, but at the same time it is strongly typed. So just because you don't need to put time does not mean you can add or subtract or multiply any type with any type. It has some strictness embedded to it. And the conventions, although the conventions are more of the thing of the Ruby people, but Python also has some conventions built in. That's why you see that most of the Python code written by most people are almost exactly the same, because it's very convention driven. Right, so now I'm going to do a very fast tidbits of Python syntax. In Python, one of the problems a lot of people with Python, and in my opinion, one of the strengths of Python is that white spaces are significant. It's like white space is, it automatically forces you to indent. Although a lot of people say that I want to control my white space or how I tab, but in general, if you want the entire code base to be readable, that's one really cool thing. There's this other convention in Python programming that, first I would like to talk about statements versus expressions. In one line, statements are basically the stuff that doesn't return much, or an expression is something that returns something. So it can be on the right-hand side of an equal sign of an assignment. In Python's cases, most of the statements end up with a colon, and the next line always starts a scope. Like you can see in the case of while, else, if, or there are like with, and all these other statements. One other thing is the else if of Python is elif. I wanted to put that on because nowadays every programming language tends to create a different syntactic rule for else and if. So yeah, that's elif. It supports multiple inheritance, and one of the most important things about Python are the operator overloading and list comprehension. Let's get into some codes. Can you guys see the codes, the slides? Is it clear? can you have to read the characters? Right. Okay. I assume it's okay. So Python can facilitate operator overloading, much like C++ and other languages. Like once you define your own objects, you can actually create operators to add, subtract, or even create a function, even call them as a function. So over here, I added a product class. Along with that, I put an add and a call magic functions, which would enable the plus sign to add two attributes. So basically, I redefine the plus sign and the bracket and the calling parentheses into my makings. So that's one way of dealing with Python's operator overloading. Okay, now comes an example of list comprehensions. List comprehension is basically it comes from functional programming practices. What it does is, in one line, it creates an iterable and it iterates over a couple of range or list or anything, and then the result is given to you directly. In mathematics, we have set comprehensions, like you say, okay, x, whereas x is this and that. So Python list comprehension syntax is much like that. So I put here 5 examples of it, starting with a very simple one where you get to square over a range of 100 elements, and then comes this other list flattener, where this is a little bit complex, where you get to take a sublist and then extract everything out of a sublist in one single line. And then you can also do it for 2 dimensions, and you can also do that for set. Python, like I said in the very first slide, that Python is an extremely powerful language. Most of its power comes from the fact that it's fully object-oriented, but at the same time you can incorporate any functional paradigms to it. There are other stuff, like there is this thing called Decorators in Python, which I'll get to. And also there are like meta classes. I'm not going to talk anything about meta classes here, but probably in the question answer session or in the meaning session I'll discuss about it if anyone wants to. And there are some advanced object-oriented concepts as well. Okay, let's start off with the functional programming in Python. In functional programming, what we do is do everything with functions, pure functions, in a way that something that gets in and something else that gets out. But there are a few things that functional programming enables you. One of them is that you can pass around a function or a bunch of codes, which they call closure, around as a right hand side as an expression, or it could also be as an argument of a method. So in other ways, you just put a function body into a method, and that method itself calls it by providing different arguments. That is one powerful feature, because this little feature enables us to create a lot of very powerful frameworks. So there are a few examples of functional programming. I've gotten a little rudimentary and started off with Lambda expressions in Python. Lambda is basically what we call functions in mathematics. Like if like we all know, if f of x is twice x plus 1, then what is f of 10? It's like 21. Python's Lambda is exactly that. It is an expression that takes in something and gives something out. But one of the things about Python Lambda is that it has to be one line, because if it weren't on one line, then probably people would have misused it and the code would have looked very ugly, especially when you're using callbacks or when you're using handlers. So that was one of the decisions taken by Guido von Rossum, and yeah, that's why it's one-liner. So we have a couple of higher order functions like map, reduce, and filter. So now, decorators is one other important concept in Python. A decorator basically is a higher order function that takes a function in and spits out another function. In other way, if you have to define a function that would take a function and add a HTML bold tag and spit it out, then you could use decorators to that. I've given the code example here. So bold maker is a function. that internally creates a wrap function that would get back the function which bool function takes, cover it up, encapsulate it with B and B, and then return that function. So whenever you're calling greet, which is a function defined under the declaration of bool maker, it would actually pass it to the bool maker and then put it and then incorporate it with the B and B and then set out the function. So you can basically the implementer does not need to know how it is bolded. He just needs to know it's gonna get bolded. This is very important when you get when one is using login required or URLs or render to decorators. So you don't need to put an if request is user all the time. You can just pass it around to decorator. So like I said, Python is also a very productive language, and obviously, I mean, it's so fun to write, and if it has so many ways of expressing this, that it has to be productive. So there are it gives you a shell, or you can just start coding directly in the shell. It also has some utilities function shells, especially the ones that I use are dir and help. With dir, I can see all the methods of that function, of that module, and with help, I can see what the module does. It has an insanely big ecosystem, which I'm going to get back to at the end of this talk. Now, it has multiple inheritance. Multiple inheritance is one of the things that makes Python productive, not because it's easy or anything, but it enables other programmers to create APIs for you that become easy for you eventually, hence making you productive. So in Python, multiple inheritance is just a few bits that it does. It facilitates a depth-first search in the class hierarchy. Now, if for example A inherits from object, B inherits from A, and C inherits from A, and D from B and C, it starts off with B, then it goes all the way above to all the parent classes that B has, and then it gets lateral into C, and then gets all the way back up. But in the new style of Python code, any duplicate parent classes gets deleted except for the last one. So the in between A gets deleted, so you get the order D, B, C, and A. So and in order to test it, you just use __ MRO to find out in what order that they're going to be used. So there are lots of ways to have fun with objects. I mean, for example, you can turn a Python's. We all know that it's case sensitive. So if you have a.save should always be in the caps lock in the case that you defined it. But in some way, you can actually change it and make the method calls into case insensitive. For example, all you need to do is intercept the operator and redefine the part that actually intercepts and sends the method, which is getAttr. So if I somehow get into getAttr and then convert the value lower and then give it away. So every time that you get a method that is not defined in your code, is given to getAttribute, and getAttribute cases it and matches it with the matching error and then converts the case. So there's stuff like that you can use it, and you can also create methods that are not actually defined. Like for example, that's what we get to see in Rails, that you get to see like person with person greater than 2. These become methods. So those things can be done in Python as well. All you need to do is override the getAttr method and then figure out, break down that particular method and redefine the codes. So for instance, I have here like get odd numbers and get less than 50 defined in the class. So I don't have those functions defined. I actually intercept it through the getAttr. So these are the reasons, these are the reasons why Python has so many beautiful frameworks, because it's very expressive. So finally, before I end this, I would like to add a few things about the Python's philosophy. What we see is many Python codes are similar, and even the ways people indent their code, even the way they write stuff are like similar. And also on top of that, in the Python communities, people talk a lot about being Pythonic and not. So that is the very reason for that is this beautiful Zen of Python. So I'm sure we all are familiar with that. But one of the few things that I personally like would be explicit is better than implicit. That's one of the reasons frameworks like Django succeeded, because they follow all those rules. And we get to see that there are so many imports and so many from X import Y in Python. That is because of this one line. And there are a couple of others to import, like flat is better than nested and readability counts. So most Python programmers somehow are become obliged to use it because they read other people's code and other people follow this. So eventually that sort of creates internal cult. And there's debate, which I think every Python programmer should read. It's about how to get proper code. So before I end, I'll just line a couple of my favorite web frameworks and tools and frameworks like Django, Twisted, Gradle, Soup, Matplotlib. There are the list, and I think there's going to be talks on beautiful Soup and Analytica later here. And that's it. Thank you.